Welcome to this video. I'm Evan, a developer on the journey to becoming an indie developer. In this episode, I'll walk you through today's development tasks and checklist. If you're interested in indie game development, let's get started. In the previous video, we finished setting up the development environment. In this episode, we'll start by creating our first Unity project. First, open Unity Hub, go to the Projects tab, and click New Project. Since this series is a 2D game development tutorial, we'll choose to create a 2D project. Here you'll see two different 2D project templates. The main difference between them is the render pipeline they use. One uses the built-in render pipeline, and the other uses the Universal Render Pipeline, or URP. I've added a brief explanation of their differences on screen. You can pause the video to take a look. If this part doesn't fully make sense yet, that's totally fine. We'll gradually cover and understand these concepts in later videos in the series. For now, we'll choose the built-in render pipeline template. At this stage of the project, it's more than sufficient for our needs. Next, set the project name. Here, I'll create a local project. Once everything looks good, click Create Project to start creating the project. Okay, this is the main Unity interface. If your layout doesn't look the same as mine, you can click here and switch to the default layout. As you can see, I've labeled the different areas on screen and briefly explained what each one does. You can pause the video to take a closer look. If you're not familiar with everything yet, that's totally fine. As we continue working in Unity, these areas will become more familiar over time. If you're not satisfied with the current layout, you can also switch to other preset layouts here. At the same time, you can customize a layout based on your own preferences, for example, like this. I'll just do a quick demonstration here. Once you're done, you can choose Save Layout to save the current layout. After saving, you can freely switch between different layouts. If you no longer need a layout, you can also delete any saved layout from here. For now, I'll switch back to the default layout and continue with the next part. In the previous video, we downloaded and installed the script editor. However, without proper configuration, Unity doesn't know which editor it should use, so we need to set that up here. First, go to this menu and open External Tools. On this page, you'll find the External Script Editor option. Click Browse on the right and link the .exe file of the script editor we installed earlier. Once that's done, let's do a quick test. Create a new script here and then double-click it. As you can see, it opens automatically in the script editor. By the way, to make it clearer what I'm doing with the keyboard and mouse, I've added a small tool that shows input information in the bottom right corner of the screen. For example, if you hold Control and scroll the mouse wheel, you can zoom in and out of the code editor until it feels comfortable for you. After the setup, you'll notice that the code shows no error messages. This means our environment and related components are configured correctly. Now let's go back to the Unity editor, delete the test script we just created, and continue with the next part. Before we start, let's cover the two most fundamental concepts in Unity: game objects and components. Think of a game object as an empty container in your scene. It can represent anything: a character, a tree, or a light. Every game object comes with a transform component by default. This holds its position, rotation, and scale in the world. But with just a transform, a game object is like a bicycle frame without any parts. You know where it is, but you can't see it or use it. So how do we make it come to life? The answer is components. For example, to make that frame a bike, add a sprite renderer, and it gets a visual appearance. Add a seat component so you can sit on it. Add wheel and physics components so it can actually move. In Unity, almost every function comes from a component: rendering, physics, sound, scripts. Components are functional building blocks that you can mix and match. To summarize, A game object is a container with a location. A component is what gives it functionality and behavior. Understanding this relationship is the first step in thinking like a Unity developer. Now let's put this into practice. First, right-click in the hierarchy window. Here you'll see options for GameObject and 2D object. A GameObject is essentially an empty object, while a 2D object automatically includes some basic components depending on the type you choose. You can also create objects from the top menu. For the purpose of this demonstration, we'll delete the empty object and keep the object with graphics, so it's easier to visualize things later. Next, let's take a look at the tools at the top of the scene view. When selecting the first tool, you can drag the scene itself. This makes it easier to browse different areas of the scene. At the same time, you can use the mouse wheel to zoom in and out of the view. Next is the second tool. If you select it by itself, you may notice that nothing seems to happen. That's because from this point on, these tools require an object to be selected first. Once an object is selected, you'll see axes appear in the scene. Based on basic math concepts, red represents the x-axis and green represents the y-axis. In 3D mode, you'll also see the z-axis. When you move your mouse over one of the axes, it will highlight. If you click and drag while an axis is highlighted, the object will move only along that axis without affecting the others. If you click and drag the center area instead, you can move the object freely across multiple directions. Next is the third tool, which controls rotation. Rotation here means rotating around a specific axis. These rotation handles work similarly to the axes we just saw, allowing you to rotate without affecting other directions. You can switch to 3D view to see the rotation effect more clearly. The fourth tool is used for scaling objects. Since this is a 2D project, we mainly adjust the X and Y axes. The fifth tool is also related to scaling, but compared to the previous one, it's a bit more convenient and allows you to resize objects more freely. The final tool combines both movement and rotation. I won't go into too much detail here. Feel free to experiment with it yourself and get familiar with how it works. Next, I'll introduce three of the most basic components: Transform, Rigid Body 2D, and Collider 2D. The Transform component stores the object's state in the scene, including its position, rotation, and scale. We can manually change these values, and the object's appearance or placement will update accordingly. The Rigid Body 2D component gives the object physical properties such as gravity, velocity, and collision response. When your game needs to handle collisions, apply forces, or simulate physics, this component is essential. Feel free to pause the video to check the detailed descriptions of each property. We'll gradually explain and demonstrate their uses throughout the upcoming practical examples. The Collider 2D component is responsible for detecting 2D physical collisions. When a character moves on the ground or runs into obstacles, this component plays a key role. Similarly, you'll learn the specifics of its properties step by step in later parts of the series through hands-on practice. Understanding these three basic components is the first step to mastering Unity's 2D physics system. All right, everyone. That's it for today's video. If you enjoyed it, don't forget to like and subscribe. If you have any suggestions or thoughts, feel free to leave a comment. Let's discuss together. Here is the checklist for the next video. There's more exciting content coming, so stay tuned. I'm Evan, and I'll see you in the next video.